Right, let's look at our setup then. So we've got, you can see on the right, you've got the circuit diagram for what we're doing. We've got an ammeter in series with a wire. And then in parallel with that, we've got a voltmeter. So remember, voltmeters always need to be put in parallel because we measure the voltage across things. Voltmeters don't conduct electricity, so we can't put it in series. Otherwise, the current wouldn't flow and we wouldn't get a reading on the ammeter. The ammeter is in series. The ammeter always gets placed in series because we are measuring the current through something. Okay, so the current through the ammeter as well. So as you can see, the setup is pretty simple. I've mounted the wire on a meter ruler, and I've already set it up so that the crocodile clip on the left is at the 0 point and the crocodile clip on the right is at the 20 centimeter point. Let's see what the table looks like. So that's the ruler, and then the table is right there. So 4 columns. We've got the length column. That is our independent variable. That is what we are changing. We will be measuring the potential difference across the wire for each different length, and we will be measuring the current through the wire for each different length, and we will then calculate the resistance of the wire at that length. So let's start by going over what potential difference means, what current means, what resistance means. So potential difference, I like to think about that as the amount of push you are going to give to the electricity, or the push you're going to give to the electrons. If you give them more push, they will want to flow faster. The speed that they flow at is the current. Yeah. So if it's moving, if there's more electrons moving through a certain part of the circuit, then the current will be higher. If you give them more push, then more will be able to flow through. Resistance is, I like to think about that as the resistance to the flow of current. Okay, if you're adding resistance into the circuit, then you are going to reduce the current. So something with a high resistance likes to stop the current from flowing. Let's think about this. So this wire that we've attached, this long length of wire, do you think that a longer length of wire is harder to flow through? In other words, do you think the resistance of the wire will be higher or lower? Well, let's find out. I'm going to turn on the power supply. Okay, so I'm turning up the voltage. I'm just trying to get the voltage at 0.5 volt here. Okay, I don't want the current to flow too much because I don't want the wire to heat up too much. So I'm reading the current on the left there. The 2 multimeters. The one in front is measuring the voltage. The one at the back is the ammeter. Okay, that's measuring the current. Right, I'm just going to move the crocodile clip to the 40 centimeter mark. Now I'm measuring 40 centimeters of wire. Turn on the power supply, and you can see the voltage has changed. So I better put that in the column there. And what else has changed? The current as well. Okay. You notice as well on both the voltmeter and the ammeter, both of them are reading negative numbers. That's nothing really to worry about here. That just means that, well, the current actually the current and the potential difference has a direction associated with it. If the current is flowing one way, it will be positive. If it was flowing the other way, it will be negative. Nothing to worry about in this investigation. Now, the wire's a little bit short. Okay, so in a minute I will be extending it here. So I extend the wire just to make it a little bit longer, but I wouldn't worry about that. Right, yeah, so we're taking another reading. Okay, I'm just going to speed it up for now, just to get to the 100 mark. Right, so a little side note here. Notice that when I turn on the power supply, I'm not getting a reading on the voltmeter. I'm getting something on the ammeter, but not on the voltmeter. I was really confused at this point. I couldn't figure out what it was, and then I see it right there. Unplugged it. It just came unplugged. So I'm now back to working again, back to normal. taking readings again. Alright, so we've got our readings. Now we are going to use V equals IR to get resistance. We're going to rearrange that. So if V equals IR, that's potential difference is current times by resistance, then we are going to rearrange that to get potential difference, or resistance equals potential difference divided by current. Okay, you can rearrange that. You can just put that V on top, and you get V over I equals R. That's what I'm doing on the calculator now. I do that for all of the lengths. What did you? I wonder what you predicted for how the resistance will change with length of wire. Well, hopefully you predicted that longer length of wire is more difficult for electricity to travel through. It's a longer stretch of wire, so it's more difficult for electricity to flow through. So you can see that the potential difference, the resistance is increasing with length. So resistance increases with length here. Right, I will just speed up through the rest of the calculations, and I'll see you in the follow-up video.